Good evening, everyone, and welcome once again to day two of the Python virtual classroom. We hope we're able to maximize benefits from the class yesterday, and we hope that we continue to add value to your knowledge over the course of the virtual classroom series. So while we're in the meeting, please let's try to observe the meeting etiquette. As advised earlier, do not share the meeting link with anyone. Mute yourself except if you're speaking so you don't distract others. Don't speak except you're called upon. And for you to indicate interest of speaking or to get attention, raise your hand or you can comment on the chat box. Let's try to maximize the chat box for engaging with the facilitator and the speaker, especially for those of us that are dialing on Zoom here. We can use the chat box, and for those of us that are watching like on YouTube, are streaming on YouTube or watching on demand, let's try to use the chat box to engage with the speaker. Let's try to pay attention as well and not disrupt the class. So our teacher for today or our speaker for today is Ridwan Amore. He started yesterday and took us through the introduction, introduced us to strings, different types of strings, conditionals, operations in Python, and he's going to be continuing today from the lecture. So Ridwan, over to you. I made you a co-host already, so you can share your screen. Let me unmute. Are you unmuted or do I unmute you? Okay, you're muted. Okay. So you can share your screen. Over to you. Welcome.
Okay, good evening, everyone. You're welcome to day two. I hope we're able to practice what we did yesterday because as a programmer, you need to practice every day. You need to stay stay conversant with your code because you might actually write some code today overnight and in the morning you'll be looking straight into you, you're wondering were you doing who actually wrote this. It happens to the best of us. So you have to practice every day. I hope everyone can see my screen, please.
Yes, we can see your screen.
Okay, all right. So where did we attempt the assignment? I said we should write a Python program that can actually dictate prime numbers between 1 and 10. And I said we shouldn't search on Google. We should try and do it ourselves. I hope we're able to find solutions to that. Okay, so today, so we discussed all this yesterday. Now we are moving on to indentation. Now, what we mean by indentation is this. I'm going to add another cell. This one by indentation. In other programming languages, such as Java or C Sharp also, when you are using conditionals and loops, you use them in block. In all programming languages, you use them in block. But you see in Java and C Sharp, the block is usually defined by curly braces. That is something like this. So this will signify the beginning of the block, and this will signify the end of the block. So anything that's not inside this block will not is not part of the function. It's not part of the condition as well. For example, if I have if here, so this is the beginning of the if statement, and this is the end of the if statement. But in Python, we don't have it like that. What we use in Python is what we call what indentation, something like this. So these four spaces or tab that you have here is telling us that what this code and this code, what I'm writing here, what I this and this, they are all part of the if block. But if I come here this way, this is not part of the if block anymore. So that is the syntax that Python use. So Python use what indentation. So most times in for your indentation you can use four space, but I will not lie to you. Most programmers use tab, even though PEP 8, which is the Python guide, they advise to use four space. Though most of us don't agree. But anyhow, just make sure that what you are very consistent. If you use four space here, if you have something like this, and look at this. If you run this kind of a code, Python will return error to you because it will tell you that what this indentation does not match any other indentation. It's trying to tell you that what you must be consistent with what you are using as indentation. So that's why most of us tend to use what tab. So if you use tab, you know what you are using one tab, you are using two tab. So that's just what this indentation is trying to tell us. So look at this now. This is a equals to 10, while a is greater than 0. You can see that what everything here from here to here, they are part of the y block. Everything here is part of the y block. But this is part of the if block. You can see it is indented. You can see the elif is back on this line with if. So these two, they are part of the what? Of this elif block. These three statements, they are part of this else block. This a, everything here like this, they are part of the y block. Why these two prints are not part of what? The block. They are just on their own. They are top level also. Do we understand that? Is that clear? Do we understand that?
Yes, we are Ridwan.
Okay, that's fantastic. So let's run this code and let's see if it will actually run. Oh, fantastic! It ran. I thought we were going to detonate a bomb or something like that, but fortunately, it was just a program. So you can see 10, a big number. So this is just the code. So I just made the code a little bit funny so that the class will not be too serious. So programming is fun. Enjoy it. You don't look at it like it's one big house that we are building. No, it's very simple. Just you can see just normal statement. Now, this instruction I added it there so that it will guide you in case you are going through it some other time. You can see that each line in the first level starts with no spaces. That is the main program. That is the main code level. That is the primary code level, and it will always execute regardless of whatever condition that is specified, because what is at the top level. But those ones that are at sub levels, they depend on what? On the top level statements. So that's what this story is just trying to explain to us. I hope we are comfortable with that. Now, what I want us to move to now, if you understand loops and conditionals, they are called containers. When I mentioned data types when we started this class, I said we have what over 36 data type in Python. We call them the native data types. That means that the inbuilt data types that Python has. There are so many other data types that you use. In the third part of this series, you'll be talking about pandas data frame, panda series. So those are also data type that were built on this fundamental data type. So these are the most fundamental data type. Every other data type are built on the native data type. So now let's talk about what the list, tuples, and dictionary. Look at this. He said, look at this statement here. He said, what if you need to store a long list of information which doesn't change over time? Say, for example, the names of the month of the year, or maybe a long list of information that does change over time. Now look at this. Look at this first one. You want to store a long list of information which doesn't change over time. There's a particular data type for it. You want to save the names of the month of the year. There's a particular data type for it. Or maybe a long list of information that does change over time. There's a particular container for it. For example, the names of all your cats. You might get new cats. Some may die. Some may become your dinner. What about, so you can also have a phone book. So you have to know what you want. It's what you want that will determine the kind of data type that you need. If you are not going to change the content of your container forever, there's a particular data type that you can use for it. If you are going to be changing your content over and over again, there's a data type that you can use. So they all have their advantages and they have their pitfall. Now, so we have these three basic containers. Although there's a fourth one, which I will mention. I'll mention if there's time. There's a fourth one that is very common. So for these problems now, Python uses three different solutions: tuples, list, and dictionary. Lists are just list in quotes, just a list of values. Each one of them is numbered, starting from 0. I'm very sure we are familiar with this 0 numbering now. We are okay with it. So numbering from 0. The first one is numbered 0. The second one 1, third 2, and so on and so forth. And remember that what if you are counting from the back or we are counting from the right to the left, the first one is numbered what? -1. Please don't forget that. If you are counting from the back, we had what? We had a negative to it. I hope you have not forgotten that. So tuples are also like lists, but unlike lists, you cannot change the content of a tuple once you define them. You cannot add items to it once you define a tuple. So dictionary is just like what? Your phone book. In your phone book, if you save my number on your contact, if you want to look at my number, what do? You enter my name on your contact and it will bring out my number. So that's what dictionary looks like also. Dictionary is just what? Is a key value pair container. That means what? Each item in a dictionary has a what? A key and a value. So that's how what items are structured in a dictionary. So in that your contact now, the key is my name and the value that you're looking for is my phone number. So if you enter my name, if you search for my name, it will bring out what? The value, which is my phone number. So that's how a dictionary works. We'll look at examples and we'll practicalize some of them. So now tuples is that the first thing we are going to do. This is an example of a tuple. You can see what now there's a saying that goes what by their brackets we shall know them. A tuple is recognized by this bracket. You see these two brackets. Don't mind this line. This line I just put it there so that I'm telling Python that what this is the continue. This line is the continuation because I don't want to extend up to this place. I don't want to extend it so that I will not be scrolling up and down. So this line here is just telling Python that what we are moving to the next line. So that it should ignore this space here. It should just move to the next line. That's what we're just telling Python here. So this bracket now is what we use to what we use to recognize a tuple. So once you have something like this and you have this bracket there, you are what? You are dealing with what? A tuple. So if I run this now, you see it's going to print out something like this to me. And we can also index it too. We can index it. You can see we can index it months of 0. That's the first one. We can index it. Can you see? We can do so the same way we're indexing strings, we can also what index what tuples as well. Do we understand that? Are we clear? Do we understand that?
Yes, Ridwan.
Okay.
Okay, Basi doesn't really understand. Can you try it again? Sorry.
Okay, let me go over it again. I hope you can still see my screen. Let me go over it again. Now, what I'm trying to say is that we have what different data types in Python. So these data types are the native data type, they're the inbuilt data type. Every other data type that you use data in the future are just what like an abstraction, the they were inherited from these native data types. So, and these data types, some of them are what they are data type. We get them as what as containers. They are containers. They can contain what different. I think they have different properties. So once you know the kind of data that you want to store, you will know the properties that you need because each of them they have their own advantage and disadvantage. We talk about tuple. The content of a tuple, they are what you cannot change them. We say what they are immutable. So you cannot change once you define a tuple, you cannot change the content. Someone asked me, said, what is the importance of defining a container that you cannot change its content? You get nothing happens without a reason in programming. I want you to remember that. Now, if you are doing network programming and you are defining a container for password, or you are defining a container for some sensitive document in a database, you must make sure that what that container is immutable. Because if it is mutable, it will be very easy for hackers to just what enter into that container, access it, then change it. But if it is immutable, the worst they will do is enter, do whatever they want to do, and they will probably leave. But if it is mutable, they will enter, do what they want to do, they will change the password. If they can't change the password while they are there, you can enter with that same password and you'll be blocking them. But immediately they enter, if that particular part is mutable, they'll just what? They'll just change it, and you'll not be able to access the database again. And that means what? They will switch the admin over to their side. So it happens very well. It's a common loophole in network programming. So you have to make sure that what those sensitive documents that what they're immutable, you cannot what change them once you've created them. So those are one of the importance of using what of using tuples. Along the way in your programming career, you would also learn some of them. You will encounter some of those things. There's no crime in getting errors in your programs. You just have to fix them. For every error you learn. So that's what tuples done. Now, so I said we can also index what tuples the same way what we were indexing strings. So we can start with what 0, which is the first item. So we can index what -1, which is the last item. Please don't forget what we did when we were doing. We can index -1, which is this. We can index for it. I'm from beginning to the third item, something like this. So we can do the same thing for what for tuples. The only thing that we cannot do is what we cannot add to months. You get once that month has been defined, we cannot add to it. So that's the difficulty, or that's the disadvantage that it has. I hope we understand that now. I hope you understand that now. Do you understand?
Yes, Ridwan, we understand. Please go ahead.
Okay, I hope my screen is still visible. It's not.
Yes, it is, but it's quite zoomed out. You might want to zoom in a bit.
Okay, I'll do that now. Just give me a second. I'll do that now. Okay, okay. Let me. What about now?
It's
What about
fine
now?
now.
It's
It's
fine now.
fine
Okay.
now.
All right. So now, list is the most popular. Yes, it's the most popular out of the containers. That's what everybody uses it. They are very flexible. You can add, you can delete. You can once you create them, you can do whatever you. They're very flexible to use. For example, now we actually were defining cards now. So this is cards, right? But you know that what? If you have this cards now, Tom, Snappy, Kitty, Jesse, Chester, one of the cards might actually die. You can buy a new card, or you could cook one to eat. Some people eat cards. So so if you want to define that kind of you want to have a container that would contain that kind of values, you need what something that is mutable, something that you can change, and that's what list does. So now this is going to what remember what cart of 0 is going to print what the first item in list cart. Cart of 0 to 2 is going to print what from the first item to the what to the index 2. That's what 0, 1, 2. Print cart that will print what this will print what before we added any another element. Now look at this method here. Cart dot append. Append is just what an English word that means what to add. So cat dot append Catherine is going to add what? It's going to add Catherine to the list of cards. So if we run this program now, you can see that what Catherine has been added to the list of cards. So append is what is the method that enables us to add an element to a list. Do you understand that? Do you follow that? Another method is what is len. Len is going to return the length of that list. Del delete is going to delete what cat 0. That is going to delete what the first item in that list. Do you understand that? Do you understand that? I think
Yes, Ridwan, we do.
okay, fantastic. Now there's something else I want to show you. I will say this is the bonus track. They call list compression. It is not every time that you are going to define your list like this. It is when you know what you are doing actually that you define the list like this. What if you have up to 2 million items? that you don't even know. They are not the one defining it. It's people that are returning it. Maybe you are collecting what items in a store or items in the market. When people come to the market, they what they do, or when people come to the market, or when people come to your house, they fill a register. So you're not the one entering it. That when they come, they're just what entering their name, and the program is collecting their name, adding it to the list. How do you compute those kind of a thing? So that's where list compression comes in. List compression has to do with what? Using conditional statement to automatically add items to a list. For example, now I can write my list. Maybe I want to create a list of even numbers. Or no, let me start with this. I want to create a list of numbers from 1 to 99. My list now, I can do it in two ways. One is more efficient than the other. Let's look at the one that is not efficient, but is not efficient and is long. I can say for I in range 100, this will count from what? From from 0 to what? To 99. My list dot append. Append is going to add what? The element to the list. Append I. Then let me tell you to print my list for me. Print my list. Don't forget, in Jupyter, the last item we printed out. What? I've looked at this. You can see that it's added it to it. Now, this is one way that we can do it. Then there's another way, which is what? Shorter, and this to me is using what? Using list compression. Using list compression. Using list compression. How do you do that? We'll just say what? We'll say X or I. I like using I. I for I in range 100. Let's print out my list. Can you see it's the same thing? So we are saying what? I, that means what? We should add what? Add I for all the elements in this range 100. Do you understand that? So this is what they call what? Using list compression. You can do so many things. What if you actually want to get what? Even numbers. Let's try something. Let's see if it works for us. Let's try something. I for I in range 100. We understand that, right? Before I continue, we understand that. Do you understand that before I continue, before I proceed? Okay, fantastic. Now let's add a little bit. The notation is just what is a list compression. We are adding items to my list automatically. Let's add a condition to it. We want to print out even numbers. So I for I in range 100. If I modulo, let's like this, if it works, then we've won. If modulo 2 equals 0, let's see what it does. You can see that what is happening? It's only giving us what? Even numbers. 2, 4, 6, 8, 10, 12. Because of added the what? A condition to it that what? The I that we added to the list, it must not have a remainder when it's divided by 2. Do we understand that? So this is just what? Using list compression. You can add you can tweak it as much as possible. Just make sure that you can see this is just normal English. I for I in range 100. If I modulo of 2 is same thing as 0. Do we understand that? Do we understand that?
Yes,
Can I continue? Okay. All right, good. Now, then this is the super dictionaries. What are dictionaries? Like I said, dictionaries are just like your phone book. You understand? They have keys and values. That means what? One item in a dictionary items in a dictionary that in pairs. One key to one value. one key to one value, one key to one value. And what this what when we talked about list, we used what the normal brackets to signify what a tuple. It's the square bracket represents what list. Now look at this now. A dictionary is represented by what? By these curly braces. And the fact that what? It has what? It is in pairs. In pair. You can see this is what? This is Mr. Andrew Person, and this is the phone number. So this is the key, and this is the value. And if you notice that between the keys and value, what is in between them? A colon. So keys value. After we are done with it, the same thing. We put a comma. Then the next item, Emily Everett, the key and the value, comma, the key value, comma, the key value, comma. Do we understand that? So if I run this now, then look at phonebook.keys. This is going to print out what? Just the dictionary keys. Phonebook.values is going to print out what? Just the values. So the keys are what? And the person Emily Everett, Peter Power, Lewis, Lame. Why these are the what? These are the values. So the same way you will look for my what? My phone number on your contacts with my name. We can also look for what? We can also look for their phone number with their name here. So if I say phone book Gingerbread Man, let me add a cell. If I say phone book let me use this man. Phone book Lewis Lame. Phone book Lewis Lame. Don't forget typo here. So it's going to look for what Lewis Lame in this dictionary, and it's going to give us the value. But you cannot use the value to look for the key. Can you guess why? You can't use the value to look for the key. Can you guess why? Can you take a guess why that's? Can you guess? Can you guess why we cannot use values to look for keys? This is because what different keys might have the same values. Different keys might have the same different keys might have the same value. So that's why we cannot use what values to look. If you attempt it, it might give you error. Might give you error. Now we can also what add element to a dictionary. How do we do that? You can see also gingerbread here, gingerbread man is the key, and this is the value of gingerbread man. So we say phone book gingerbread man, this is the number. Yeah. So is this not my number actually? So if you run it now, it has added it to it. So if you tell it to print out the dictionary, it's going to what add gingerbread man to it. So now let's look at a complicated program. It's not really complicated. So you can see that I added a lot of comments to it. So this, please, I encourage you to add comments to your program so that it will be readable for every other people. People don't need to start stressing their head to understand your program, especially if you are someone like me that used to use strange variable names. So add comments so that people can understand your program. Now look at this now. Ages. Look at this. What an empty dictionary. Then what do we do? That we had what ages: Sue 23, Peter 19, Andrew, Karen 45. Karen, are you 45 years old?
No, real one. I'm not 45.
Okay. So now we use the function ASCII. We are not going to use the function ASCII. Because what ASCII has been deprecated. ASCII was present in Python 2, but in Python 3, there's no more ASCII. What we just have is this is how we use it now. So you can ignore this. So we don't have ASCII anymore. ASCII was in Python 2. Now we are in Python 3 now. So the same thing for this. Now let's go on. Let's move to this program. Now it said if Sue in age.keys. Now let's go back to our list. Then let's go back to our list. Now look at this my list here that we have here. Let's do something to it. We can actually iterate something here. Look at this. If I say if 4 in my list do something, we can actually what? It's just like normal English that we use. That's what we wanted to come and do here. If Sue in H, this is just saying what? If Sue is in edges dot key. Remember that what? This is going to what? This is going to print out what? It's going to print out a list of the keys of their dictionary, right? So this is saying what? If Sue in edges dot key. That means they say what? If Sue is in edges dot key, but we don't put the is here now. We don't put the is here. So we just what? We just say what? If Sue in edges dot keys. Print Sue is in the dictionary. She's then this what this will give us what the age of Sue. If you look for it in the dictionary and print out the age of Sue here, years old. Else print Sue is not in the dictionary. That means what? If this fails, this will run. Now so we come here to so the following people in the dictionary. This is going to print what the keys. That means what the names of people in that dictionary. Then this is going to give us what the keys as well. Now look at people are age the following age the value. This is going to what? This is going to print out what the values of that dictionary. Then this is going to what assign this to what to a value, and this will give us a list. Then we'll print it out here. We print out everything that we just did out here. So if you run it, you're going to have something like this. Sue is in the dictionary. She's 23 years old. The following people are in the dictionary. So everything, so all these jargons that we just wrote here, almost 58 line of code that we wrote here, this is also what it's trying to do. Do we understand that? Do you understand that? Can I continue?
Ridwan, nobody. Yeah, okay, yes. Somebody has commented. Yes, we can, please.
Okay, fantastic. Now, so how do we accept user input? In case you are running Python 2 on your system, there are ways you can accept user input. In Python 2, we used to use something they called it was raw input. We had raw input, and input. We had raw input and input in Python 2 point and 2 points. But in Python 3 points, everything has been deprecated to just what input. Now, the funny thing about this input is that what it will always return a string. Input will always return a string. If you don't want, if you know that what your users they're not going to input a string, or you don't want them to enter a string, what you want them to enter is a number. You have to what specify that what you want a number. For example, now you see this one that I said here now. Look at, I'm going to say, you can see here, this to accept an input and automatically make it a string. Whatever you enter here, it will become a string. Now let's do this now. Let me run this. And I'll tell you to print this now. Let me run this. Look at it. It tell me to enter my value. Let me enter number 1, 2, 3. Now I entered. Okay, let me enter letters first. Let me enter hello. Now let me say print imp. Hello, a string. Let me check the data type of imp type. A string. Let me run this again. Let me enter number 2020, a number. We've done that. Now let's check the type. Still a string. So whatever you enter here is going to what? It's going to be a string. If you don't want it to be a string, for example, if you don't want it to be a string, you want it to be, you want to what? You want to accept a number. Maybe you want to use it in a calculation. You must specify that what? You want a number. So, and you know, we have a different data type for number. We have integers, we have floats. It depends on the one you like. So I can do this now. Let's assume I want to what? I want to get two numbers and I want to add them together. I can say x equals input. This is just a prompt. I'll enter the first number. I'll just put this here and I'll put space. Y input, enter the second number. Look at what we have here. Enter the, so if they want to print x plus y, if you do this, we are going to get error. Or okay, is still going to do this because it's going to concatenate it together. Let's do this now. Let's attempt it. I like this stuff. 12, 13. What happened? It's going to concatenate it because what? It believes that what x and y are both what strings. It's going to concatenate them together. So what we don't want to concatenate them. We want it to give us what the arithmetic sum of x and y. So what do? We declare what we do what they call what data casting. So we put what integer here. Int. You put integer to show that what we want is what is an integer. What we want is an integer. So if we do this now, enter 12, 13, we have 25. Fantastic. That's what we want it to do. Remember, if you don't want integers, you want floats, you can put floats there. You understand? So you can use integers, you can use floats, whichever you are comfortable with that is suitable to your data. Do we understand that?
Yes, we do. But a question from the chat section. Can you go over? Can you repeat the part before you start talking about this concatenation? The paragraph just before this. So someone from the chat section.
Okay. Input is going to accept values into the program. It's going to accept value from a user. Maybe you want to write a program and you want people to enter their values. It's going to accept it, but naturally, input was going to convert your data, your value to a string automatically. So if you don't want to,
not the part on input, the part on dictionary.
Okay, dictionary.
Yes.
Okay. So the dictionary is a simple thing. Like I said, when you have your phone book, your contact, if you have my number on your phone and you want to look for my number, you start on my name, read one, right? And to bring up my number. So read one there is the key. The value you are looking for there is the number. So that's exactly the way your dictionary behave. Look at this phone book that we have now. We have Andrew passing. Look at this phone number here. So this is the what? This is the key, and this is the values. So we can access all the keys with dot keys. This method dot keys is going to print out all the keys, and you can access all the values with dot values. This is going to print out all the values of that dictionary. So that was what happened here. So we can also the same way you look for my name on your phone that it brought up my number. You can also do that here as well. Look for the phone number of Lewis Lim. So if you run this now, it's going to search through the dictionary and obtain the phone number of Lewis Lim. If Lewis Lim is not in that dictionary, it will give us error. If I put something here now, it will get key error. It's telling us that Lewis Lim is not in the dictionary. So now we can also add a contact to our phone book by doing phone book gingerbread man equals to this phone number. That's understandable, right? So that's what we did there too. We define an empty dictionary here. We access the keys and we check if Sue is in the keys of the dictionary. So this lets us say if Sue is in this, but we are not using is here. You get, so else do this. So it's pretty straightforward, and you can follow the comment as well. So if we run it, so that's why we had something here. Now, I wanted to mention something here. Now, since we've declared this thing to be an integer, if your user enters a string, if I enter hello here, it will give me error. Why? Because you've declared that it should be an integer. Don't worry, we are going to and your program will crash. Immediately it hits this kind of error, your program, even if you have 1,000 lines of code and it hits error at line 3, everything will crash. Everything will crash. So we're going to talk about how to catch errors and how to deal with them so that your program will not crash. It will not crash. Another way is what you can tell them that what, and you can put it here that what they should enter number, they should enter string. Function. Okay, yes, this is where it gets interesting. All these programs that we have been writing. What if you want to you've actually written a very good program and you want other people to be using it? The same way we've been using people's program now. Or look at all this function. Look at this input. Look at this input. How would this input? Somebody wrote it in Python. How can you write your own function so that what other people can use? For example, now, how can we write a function that would just be that would add 5, or that will multiply whatever we supply to that function, that will multiply it by 5, or that will get the even numbers between so range. How can we define a function that you can just put the function there and people can be using it? For example, now if you go to some website, they will tell you to what they have, what functions that can help you to get prime numbers, function that can solve quadratic equation, function that can solve simultaneous equation. How were they able to do that? You can do it yourself too, once you just understand what functions. Now this is the syntax for a function. Def, this is how we define the function. So parameter 1, parameter 2. Now I must tell you here that what not all function takes parameter. So parameter is just what the arguments that you supply to a function. Not all functions takes parameter. Some functions are just what they don't have parameter. They're just what you just use them. You cannot change the parameter that you have there. So the same way you can see that it has been indented as well. So indentation, 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 indentation. So return is going to what? It's going to return. That's the value that it will return to the program calling the function. Look at, we will see that we'll see that now. Now look at this. This is def hello. Def hello. Def hello does not take any arguments. Def hello does not take any arguments. So what does it do? Once you call hello, it's going to print what hello, and it's going to return 1, 2, 3, 4. What is the difference between these two? Now let me say print hello. Okay, we've not defined hello. Hello 1, 2, 3, 4. If I remove this print hello, if this print hello is not there, it will only what? It will only return 1, 2, 3, 4. But if you didn't put this print there, it might not do it. If I say now, let's look at this. If I say a equals to hello, and I say print a, I don't even use print. Let me just put a. 1, 2, 3, 4. Now, if you assign a function to a variable, the same thing we did here. We say let a be equals to hello function. This hello function, let a be equals to hello function. The value that a will take is the return value, not the return. That means what? You call me, this is what I will return. You call the function, the value that the function will give you is the what? Is the return. You call the function to perform some particular operation. The outcome of that operation, that is what the value is going. That is the value that the function will return. So return is just what the statement. That's any statement after return is just the value that will be sent back to the program that's calling the function. Do we understand that? Now let's define a function here. Let's define a function that can multiply two numbers together. So def mul is going to take two numbers, a comma b. Then what it's going to do? It's going to return their product. Return a times b. Return a times b. So if I call this function now, if I say what? If I want to call this function, I'll say mul 3, 4, 12. If I assign this now to a variable, if I say let x be equals to this, you understand that? Let x be equals to this. What is our x? Our x is what? 3 times 4, right? So if I say x times x plus 4, now 16. Because what x is taking the value, the return value of this what? Of this function, and you're not adding 4 to it. Latifat, which part do you not understand? the return function. It's just like, okay, if you send me a message, the feedback I'm going to give you, that is the return value. That's why. Do you understand that? So the feedback that the program. So if now look at this place now, I am calling more function now. I am calling more function. No, it's not a return function. It's a return statement. A return statement. This is the function. Everything here is the function. So this is the name of the function. Mol is the name of the function. So if I call on mol now, I want to send mol a message. So the feedback that mol is going to give me is this return. Is that clear now? Fantastic. So now I want us to define a small calculator program. I want us to define a small calculator program. Now look at this, our small calculator program. It's very simple to understand. We define what loop equals to 1, choice equals to 0. This loop and choice is just a variable name that the one that they are going to control what we are doing. What I say, while loop is the same thing as 1, do this. That means what I want to continue to what? To repeat this program as long as what? Loop is the same thing as 1. If I want to tell it to stop, what will I do? I'll just change the value of loop. That's what I did here. So while loop is the same thing as 1, what it's going to do? It's going to print what? Welcome to calculator.py, that's calculator Python. Your options are addition, subtraction, division. So now look at choice now. So this is our choice now. So we're going to tell what? So this choice is going to what? Accept input from the user. So they're going to choose one of these. So once they choose it, now look at what I said here. If choice is the same thing as 1, that means what this person wants what? This person wants to perform addition. So add 1 is going to what? Request for the first number. Add 2 is going to request for the second number. Then to print out what? This. Then it will go back what? It will go back to this and run it again, and you enter your choice. But if you enter choice 5 is what? Quit calculator.py. If you enter choice 5, what happens? Loop becomes 0. And once loop becomes 0, the program will stop, because what? The program will only run if loop is the same thing as 1. So this is I just define this calculator program so that we understand what how loops and conditionals can control the flow of your program. So let's run this now and see what it does. Choose your option. So I'm choosing 1 because add this 12 to 13. It's giving us, look at this. It gave us 25, right? And it's still running. It will continue to run as long as what you've not what change the value of the loop. So if I say 5 now, what will happen? Thank you for using calculator.py. It will quit. That's all. Because what? Immediately you select option 5. Immediately select option 5. This what loop will become what 0. And once loop becomes 0, the while loop will stop. Do you understand this small calculator program? Do you understand this small calculator program? Do you understand this small calculator program?
All yes, right. Ridwan.
Okay, good. Now, but this calculator program is looking a little bit cumbersome. We could actually use what? We can actually define what? A function that will perform most of what we have here. So let's come here and look at this now. So here now, I'm going to define what? The menu. Def menu. You can see that menu does not take what? Does not take any arguments. Print all of this. Then what is going to return? It's going to return the what? The choice. It's going to return whatever you choose. So it's going to return the choice. Now look at this now. So this is what our addition function, subtraction function, multiplication function, division function. Now this is the calculator program. Now look at this. How many lines do we have here? We are up to 47 lines in that first calculator program. Then how many lines do we have here? Look at just these few lines. And we can use that function to do whatever that we want to do. So now look at this now.
Ridwan, sorry, please, yes? Can you go over the calculator program again?
Okay. The long one.
Yes, please, the long one.
Okay. So now, what I said was I want us to understand how loops and conditionals control the flow of our program. Now look at this. Look at the why loop is the same thing as one. I explained that while. Why loop? What does while loop do? While loop will continue to run a program as long as it is true. That's what loop does. As long as their condition is still evaluating to true, that program will continue to run. So if it never returns false, it will be an infinite loop. It will run forever until your system crashes. So now, if you want this program to stop, what do? We just need to what? To change the value of loop. So I'm using that loophole per se to control the flow of this program. So if you want to quit this calculator, I'll just what? Change the value of this loop. So look at this option 5 now, that is quit calculator of py. I'm going to make sure that what if you select 5, this value of loop will change to what? To any other thing. If you change it to any other thing, this calculator will stop. So now choice is going to accept what? User input. So if your choice is 1, which is this addition, look at it. You've already told it what to print 1 addition. So if the user chooses 1, it's going to accept what? The first number, then the second number, then it's going to print out what? The addition. The same thing for choice 2, subtraction, multiplication. So if I run it now, choose your option now. If I choose option 2, if I have what? 13, 12, the second number I have 3, because it printed what? 12 or 3 minus 12, that's what? Minus 9. Now then it goes back to the beginning to print what? This option. So if I choose another option now, multiplication, let me choose multiplication here. 12, 3. You can see 12 times 2, that's 24. Then it goes back again. It will continue to run as long as what? The value of the loop has not changed. But if I choose option 5, what happens? The program will stop running, because what? If you choose option 5, leave choice equals to 5, the loop will become what? 0. And immediately loop is no longer 1, your program will stop. Do we understand that now? So, and I said what? This program is very long here. You could actually shorten it using what? Defining what functions here. And these are the this is the menu function, this is the addition function, subtraction function, multiplication, division, then this is the what? This is the program. Right? Do we understand this? Okay. Thank you. Now we are coming to the end of this section. Can you choose multiple options in the calculator for a single function with several operators? I'm sorry, I don't understand this. This is very ambiguous. No, you cannot. Input is going to accept one option. Why do you want to enter 2 options there? Input is going to accept one option. Input accepts one value. No, input accepts one value. Yeah, this is just a simple calculator function. It is not the actual calculator function. This is just what simple calculator. If you want to define your own calculator function, that what people will just enter 4 plus 5. It's going to calculate it for them. People are going to enter 4. They're going to enter plus 5, and it's going to do. You can do it. It's not something that is very difficult. You can develop your own calculator program and convert it to an application and send it out to people. People start downloading it and they start using it. It's not something that is difficult. This is also what I'm just using this simple calculator program to explain the flow of a program. So you can see that what we didn't write addition or we didn't write subtraction inside it. What we did was just enter some simple variables that we can easily operate on. Can you use multiple functions? E.g., let's say a quadratic equation. If you want to write a function to solve a quadratic equation, you can do it. You can do it. You can do it. You can do it. You can use the almighty formula to get the root of a quadratic equation. You can do it. It's not something that is difficult. You can do it. Let's attempt that. Okay, I don't think we have time. It's not something that is very difficult. I hope all of us remembers the almighty formula. So if we what we're just going to do is we're going to define chord. That's our quadratic formula. So we're going to say what? Enter the value of a, b, and c. You remember that what? The solution of a quadratic equation is minus b plus or minus square root of b square minus 4ac over 2a. I hope you remember that. So those a, b, c, these are the coefficients of that quadratic equation. That's what we're going to use here. So and how do we solve that? We know that what our first value x1 is equal to what? Is equal to minus b, right? Plus what? Plus into bracket our what? Our square root, right? Our square root is math is the square root of b square of b square of b square. You can say b square, something like this, b square minus, you can open another bracket so that Python will understand we are doing 4 times a, 4 times a times c, 4 times a times c, then everything divided by what? By 2 times a, 2 times a. So we're going to copy this down. We're going to what? Copy this and put it here. So this is going to be our s2. Our s2 is now going to be minus b what? Minus this, right? And b minus, so that it will not everything will rhyme, so that we don't want to leave everything for Python to solve. Let's put the bracket there so that it will do the numerator first. Okay, or no, okay, minus b is supposed to be outside. Okay, yes, minus b is outside, so it's going to do this, it's going to do this, then everything here like this. So now we are going to what? Return x1 comma x2, and that does the what? That would be the root of our quadratic equation. So anybody that calls this function now, if you call this function and you enter your what? You enter your value a, b, and c, it's going to just return x1 and x2, and that will be the root of the quadratic equation if they have a root. If the root is not a complex number, because everything that we are using here is what operates on integers and floats. But if it's a complex root, then you have to do more things. This is a simple quadratic function. If you want the quadratic function to be very robust, you have to add what? More things to it. I hope you do understand that now. Now, errors and exception, if you have not seen them before, then you're not trying hard enough. There's no way you will not make mistake when you're programming. So if you make those mistakes, don't be sad. Errors teach you. You understand that? Errors, they will teach you. For example, now look at this program that we are doing here. Look at this program. Def menu list question. For entry in the list that we enter here, print 1 plus list index of entry. Print this. Now let's run this program. Let's run this program. If I enter 1, look at this. What is telling us? It says what? Type error. Now you look at the error very well, and you what? So that you be able to what? Identify where the mistake is. He said what? Unsupported operand. Type for what? For string and integer. He's saying what? This is the operand minus for string and integer. That means saying what? It cannot what? Perform that operation on a string and an integer. And he's saying the error is what? Is at what? Line 11 going to line 6. So this is where the error came from, and this is where, so this is the source of the error. It's telling us that what? 1 here is the integer, but this one is what? Is a string, because we said what? Input, we always convert your whatever you enter here to a string. So you cannot subtract 1 from a string. So that's why it was raising the error. Do you understand that? So what do we do to it? We add what? Integer at the back, so as to what? Convert whatever we enter here to a what? To a number, so that what? It can subtract 1 from it. I hope you do understand that. So if I run this now, I enter 1. What happened? Another error. It says what? It can only concatenate string and not integer. We've solved one error. After solving that error, another error came up. So now, so errors will always teach you. Pay attention to them. It's saying what is at what? At line 12. Your picked answer plus 1. What happened there? It's what it's attempting to what? To do what? It's attempting to what? To concatenate what? This string and this string. And remember that what? Our answer here is what? Is that it has become what? An integer. So it cannot add what? This integer here to this what? To this string here. So that's why it's getting another error. So what do? We can convert what? This everything here to what? To a string. So what do? We just add what? String to it. So this is going to what? It's going to convert what? The answer here, answer plus 1 to a string. So even if it's a number, it's going to be what? Be behaving like a string. Do we understand that? Do we understand that? So let's do that here. So now we don't have what? We don't have errors anymore. Do we understand that?
So Ridwan, the feedback is you should please come again.
Okay. Now we started from here, right? Let's run this program. Let's enter, choose this. What happened there? We have this what? We have this error here. Unsupported operand, which is what? This minus for string and integer. It cannot subtract integer from a string. And it's telling us that what? The source of the error is this line 6. So let's go to line 6. What is happening there? In line 6, we have what? Input question. Input question is going to return a string, and 1 is an integer. So it cannot subtract 1 an integer from a string. So what do we need to do? We need to what? Convert what? This input to an integer also. So how do we convert to an integer? We do what? Typecasting. We add what? Integer at the back. So int, this is going to convert what? Everything here to an integer. So you cannot subtract 1 from it. So let's run this program now. So we don't have what? Error at that line again, but we have error at line 12. It says what? Can only concatenate string, not integer to string. So it can only concatenate two strings together. Now, this is what? This is a string, but this is what? This is an integer. This is going to give us an integer. And it cannot do what? It cannot join them together. So we need to make this what? A string as well. So we need to make this line. We need to make this line a string so that it can what? It can join these two together. And how do we make it a string? By just adding what? This to it. So to make it a string. So if we run this now, then to what? No more errors. Do we understand that? Now, the smart way of doing this so that your program will not crash is this. Is this what we call what? The try and except block. Now, this is our what? This is our answer here, right? It says what? Try, you picked answer this, except type error. Remember that we've been accepting type errors this morning. Now, this is going to print the error, and this is going to print what you picked. So it's going to accept the type error. It's going to catch the error. It's not going to allow your program to fail. It's going to catch the error. Instead of your program crashing, no. It's going to catch it, and it's going to do something else. And it will continue. So immediately everything here has run. If you have another code here, this one will just continue running. So that thing that you believe will give rise to error, you might put it to what? In a try block. For example, if I have two lists now, I have list 1. Let me use this as list 1. I have x for x in range 1 to 100 in step of 2. I have list 2 to be equals to I for I in range in range 10, and I say what I want to do for I in list 1, for I for J in list 2. Print 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 uh print I divided by J. Print I, okay, this is too much. Let me use 10. Let's go in this. What, look at what happened. It says error, zero division error, because what it cannot, we can in on the real number plane, even on the complex plane, we cannot divide by 0. So this is going to give us error because we cannot divide. So instead of having this, I can have what a try and what a step there. So I can do something like this. For I in this, I can do this and do try this. Then I'll say except this particular error, except this error as E. So what should you do there? I can just tell it what print you can't divide by 0. Then let's run. Look at what happened. So it says that you can't divide by 0, and what it continues. So your program will not crash if you can what if you can be smart enough to to anticipate what your user might type, so that you can quickly catch the error, and it will not crash your program. I hope we do understand that. Do we understand that? Do we understand that?
Yes, Ridwan, please go ahead.
Do we understand that? Do we have any question?
Yes, Ridwan, we understand. Please go ahead.
Okay, so in this section now, we've covered what functions are, we've covered what errors and exceptions, we covered indentation, we covered list dictionaries and tuples, we covered how to use list compression. You can even do dictionary compression as well. You can do dictionary compression. I don't know. You can do dictionary compression as well. You can do dictionary compression. Now, for example, okay, this was where we did our dictionary. Our dictionary. So we can have a dictionary compression, something like this. Like I want to create a new dictionary. I will say my dict to be equals to. Then I will say X to Y. I'll say X to. Let me. I'll just use a default value. Let me use 1. Then I will say for X in I have my list here. My list here to be, let me Ade Bola Peter. Okay, this is Ade Peter, comma Andrew. Then I can say for X in my list. If we print out my dict now, okay, what's that for? So now, if you do this now, you notice that what every item in my list has been added to what has been said what our 1 is now their value. So for X in my list, so X here is on the key part. So it's going to what? It's going to populate this X with what? With everything in my list. So you can see that what every item in my list are there, Bola and Peter 1. But you know, there might the values might not be 1, right? So I could actually say do this for I in my dict. If you do this, you are indexing through the keys. If you do this, I will become the keys. Then we'll say what? My dict of I, my dict of I, or you can be very, very, very skillful, very skillful here. If I is the same thing as Ade, then of my list of Ade equals what? 20 equals 23. Else if I is the same thing as Bola, then my list, okay, don't say my list of I instead of my list of I, because I is now added there. My list of Bola, my list of I here equals 21. Then I can now put else my list of I equals 12. What's that? Oh, sorry, not my list. I was if I, nobody said anything. It's my dict. I was not. I was it's my dict. So you can see now that what Ade's age is now 23, Bola is 21. Now, since we said what else, so every other item that is not Ade or Bola, their age will be 12. You can see that Peter and Andrew are 12. So if you understand this, I think we are good to go to the next section. I think I'll be ending my own section at this point in time. So if you have any question, you can ask now. If no question, I want to say thank you, everyone, for having the patience to learn and having the patience to listen to me. So if you have any question, you can ask now.
Okay, Ridwan, thank you very much for that session. I hope that most of us that tuned in have been able to go about the basic syntax, for Python, as well as dictionaries, classes, lists, and then basic operations as well, because we'll be employing some of these in the classes going ahead. For those of us that were not able to join the live session, please, you can watch the on-demand session on our YouTube channel. So our YouTube channel is EAGNIGYP, right? And in the mail sense, the link is available. Sorry, the YouTube is EAGEYPNIG. EAGEYPNIG. So in the mail sense, the links are available. So you can go ahead and watch it at your convenience at a much slower pace if you want to. Tomorrow is day 3 of the class, and tomorrow we'll be looking at introduction to Python for data science. So what we've been covering for the past 2 days has just been an overview, but then we want this classroom to be more application inclined. So tomorrow we're looking at introduction to data, Python for data science, and then we'll be also looking at basic statistics that you need to be aware of or be conversant with for you to use Python for data science. So we hope that you are able to tune in. Okay, so Oreva, I see your question. Are we going to be taught data analysis using Python? Yes, we are going to be touching data analysis. We'll start tomorrow, and then we'll go deeper into modeling, regression analysis, and GUI interfaces in the classes coming. The modules are packed. You can go over them once again to get familiar with what you're supposed to deliverables. Also, please be reminded that the all the materials for the class are available on the classroom drive. The materials for module 9, which is the GUI interface, has not been uploaded yet, but it will be uploaded tonight. So for those of us that have already downloaded all our materials, you might want to go and download the module 9 folder ahead of the class. So at the end of the class, we are going to have a project, and then if you want to partake in the project, don't forget to register the link available in the mail trail as well. So after the project, you'll be awarded certificate, and the whole package goes for a stipend of 5,000 naira. So for 5,000, you work with the project, and then the project will be reviewed, and then you'll be certified. So don't forget to register with the link if you're interested in the certification and the project. So I think we've come to the end of this session, but I think some people have questions. So I think we'll just take the questions and then we'll call it a day. So Israel Umana.
Okay, and somebody was most of you are always complaining that your kernel does not run, your Jupyter is fumbling. If your Jupyter is busy or you've run some code and your Jupyter is so busy and you don't know what to do, you see this particular button that there is restart kernel. Immediately you restart this kernel, or everything that you've done from the beginning will be lost. But you'll be able to start afresh if you restart kernel. But sometimes the kernel might not want to restart. It might not be, because you can stop if your program is running and you want to stop, you don't want to finish. You can always interrupt kernel. If you interrupt the kernel, the program will stop. For example, where's that program that we were running that was much the other time? Okay, this particular one. If I'm running this now and I want it to stop, I can just stop it. It will stop. It will interrupt it along the way, and it tell me what keyboard interrupt. But there are some programs that some programs will not want to interrupt. So you can just you will start okay, but if you start your kernel, all the outputs, everything that you've done before will be gone. You have to start from the beginning. So this is the last result. Restart your kernel. So you can come here, kernel, restart, or you can reconnect. Maybe you lost connection. If you lost connection, you see here that you can see trusted. It will be telling you what connect. It will be telling you not connected here if you've lost connection to your kernel. So you can just click on reconnect, or you shut down the kernel and you restart it, or you start and clear output.
Okay, so Israel Uwana, I don't know if you're still on.
Okay, thank you very much. My question has been answered by the teacher.
Okay, no problem. Okay, so if there are no other questions, are there any questions in the next 1 minute? You can raise your hand if you have a question. If not, we'll call it a day.
All right, I think there's no question. I think all is well and good. So next week we move on to the next module. So
Tomorrow we move on.
It's tomorrow. Oh, okay. Tomorrow is Sunday. Yeah, I forgot.
Yeah. So tomorrow we move on to the next module. So I'll be sending a calendar invite again, but please let's be aware that the time is 7 p.m. West African time, right? So that we don't come late or you don't want to miss out, because tomorrow is going to be very packed. So what we've been doing is basically an introduction into Python, and then from tomorrow we're going to start looking at data analysis and data science using Python. So you don't want to miss out. So thank you very much for joining in, and we look forward to an enlightening session with you tomorrow. Cheers.